So, what is Infoblox? We are the leader in the secure DNS, DHCP, and IP address management space. So very, let's say, unique space, kind of niche, but we do it for last 20 years. So comparing to the cognacs yesterday, we are like XO, probably. And yeah, there are plenty of customers, of course, using it, so that's it from the marketing perspective. Now, the title of presentation is how threat actors are using DNS. Who believes I can tell that in 20 minutes? It's just not possible, right? But at the end I will show you how you can learn more about it. So just wait till the end. So what you see here is a cyber kill chain, right? So it's a very general, very high-level model how advanced attacks are done. Basically, no matter where the attack is, there are some phases of the attack. Even in the war, actually, also the same phases, more or less, are there. And everything always starts with reconnaissance, right? This is a very important part of the preparation for the attack, because everything depends on that. If the information, basically, which attacker will get about the victim will be not full, not correct, then probably he has bigger chance of failure, right? So they usually try to get as many information as possible. How they use DNS here is basically they try to get some information about IP addresses used by the victim. Usually from the DNS names you can get some clues about applications being used in the victim infrastructure. Sometimes you can even find private IP addresses, because we are all humans, we do mistakes, and DNS administrators also do a lot of mistakes. You can get this in an active way, by doing some kind of active scanning, such as DNSSEC enumeration, trying even to download the DNS zone, which usually will not work, but sometimes you might be surprised. But you can do it also in a passive way. You can get a lot of information from passive DNS database. So basically in the internet there are a lot of passive DNS sensors gathering copies of DNS queries, and then you can ask such database what you have seen about this domain. What were the IP addresses, what were the hostname queries, and so on. Then there is a weaponization phase where the attacker basically prepares based on the preparations, based on the information he got. From the DNS perspective, they will probably need some DNS servers or a domain name at least. They might need some, part of the code in the malware which will somehow use DNS in many different ways. Yeah, but it doesn't use DNS as such yet. Then we have a next phase, the delivery phase, where actually the malicious content which was prepared before, it's delivered to the victim, right? And this can be delivered directly, like the attachment to email, to message, on whatever channel, or it can be delivered indirectly. So the user, for example, have to do something to get the content on the endpoint. And if this is done indirectly, very often it is done with some kind of link, which is basically an URL, which contains typically fully qualified domain name. And here it's a first possibility to act on the DNS as a defensive side, because of course, if, for example, user would click this link, then the domain name needs to be resolved to the IP address, and then the DNS resolver can act, for example, check list of malicious domain names and do not resolve if the domain name is on the list, right? And usually when people think about using DNS in defense, this is what they think about, right? Very simple tactic, let's say, from the defense perspective. You just have a resolver, list of malicious domain names, and you do not resolve if something is malicious, right? But this is based on the IOC, let's say. This is IOC level protection, which is not really that great. So we will not talk about it today, because it's too simple. Then we have exploitation phase, where the attacker is actually exploiting some vulnerabilities in the systems. From the DNS perspective, it might be exploitation of vulnerability DNS server software, or also in DNS client software, which is especially true in the OT networks or IoT networks, where basically the host devices in IoT, they have very weak security, they have very bad code in TCP/IP stack, and they do very stupid things. But today we will not talk about it. Then we will have installation phase, where the malware is actually installed on the host. It could be, of course, anything. It doesn't have to be an endpoint. It could be a VPN concentrator. It could be a printer, UPS, whatever has CPU, memory, and the network connectivity, right? In this phase, DNS is not used that much. It's more happening on the host, but immediately after installation, usually the next phase is starting, so there is a command and control phase. The infected device is trying to register at the C2 server, is trying to send some basic information about the infected host. It waits for the commands to be executed, then it executes the commands and get back with the replies. And this has to be done over some channel. So in C2, in my opinion, let's say from all the phases, DNS is mostly used in advanced techniques in the C2 phase. So if you match, for example, MITRE techniques, you will find more techniques using DNS in the C2 phase than any other phase. So for example, right, to connect to the C2, we need an IP of the C2 server, right? So it could be, and it sometimes is, hard-coded into the malware, and the connection is direct, but usually attackers try to have some kind of redundancy, that if something will not work, they can use the other channel. For example, if the one IP will be blocked, they would have possibility to change the IP, right? So it's much better to use a DNS name, domain name, because then the IP can be easily changed. Even, every minute, every second, every query, actually. Then, this domain name could be hard-coded in the malware, but also could be downloaded from somewhere, or generated. So there are some techniques like DGA, so domain generation algorithms. I will show one, rather more newer. It could be also downloaded from legitimate services, like I have seen at least 4 malware families downloading names of the C2 servers from the cryptocurrency services, so legitimate cryptocurrency services. Then, finally, if the IP is there, we need to connect as a malware, right? We need to connect to the C2 server and ask for the comments. So this has to be done over some kind of channel, and DNS is one of them. How you send data over DNS? Basically, you send the DNS query, which have data encoded in the DNS name, usually host name and first subdomains, right? Domain name is C2 domain name, but the host name contains encoded information. Then you get the reply from the C2 server, and this reply can be different. Could be an IP address, could be TXT record, whatever you will use, right? But if the C2 replies with the IP address, it doesn't necessarily mean it's an IP address. From the attacker perspective, it's just 4 bytes of information. Or if it's IPv6, it's 16 bytes of information, right? If it's TXT record, text record in DNS, then you can basically put a lot of data encoded, for example, with base 64. So this is the way how the malware and C2 will communicate. Then we have actions on objective phase. So where the attacker is actually, achieving what he wanted because he did this for some reason. So this could be getting sensitive information. This could be, impacting services from the victim, served by the victim. Could be, of course, encrypting data and requesting ransom. And DNS is usually used in two objectives. So either it will be, for example, DDoS attacks, so impact on the services. And DNS is obviously one of the most typically used protocols for DDoS because it's based on UDP, typically. But also it can be used to steal information in a very stealthy way. So usually these are the two, let's say, use cases for using DNS in the last phase. Okay, let's move to one example because we don't have too much time, so there will be only one. But it shows how it works more or less. So here we have a TrickBot variant called Anchor DNS. So TrickBot is a Russian group which is basically infecting as many computers as possible on the internet and then selling malware as a service. So you could basically request from them, buy from them, different kind of services on infected hosts, right? Typically, TrickBot was using command and control over HTTPS, but if they infect a computer which is of high value, and from their perspective it would be any computer in financial sector, or for example, any Active Directory controller in any sector. Why C2 over DNS in this case? Let's take example of AD controller. If you, as a threat actor, would start doing C2 over HTTPS from Active Directory controller to some IP in the internet, then obviously it's a not typical behavior of AD controller to reach somewhere to unknown IP address, right? But on the other hand, what AD controller usually have is Microsoft DNS on them, which means, and they are first resolver for the company, so it means basically you will have plenty of DNS queries from all the hosts in the company, and you send plenty of DNS queries to the internet. So if you hide in that, it's much harder to find you as an anomaly, right? So that's why they have this variant. If they, let's say, after initial infection, they will recognize it's an AD controller or financial sector computer, basically they download the Anchor DNS module. The Anchor DNS basically hides information in the query, as you see. So here is encoded data, and you have some C2 domain name. And this encoded data, after the coding, you can see it's a campaign name, host name, Windows version, client ID, and there is finally some payload. So this is hidden inside of DNS query, right? From the reply perspective, we can look here, because here we have an example of using Anchor DNS. Anchor DNS is just a module which is used to actually do other actions later. So for example, it was seen together with Ryuk ransomware. So basically they deploy Anchor DNS to control the machines and do the things they need to do to deploy the ransomware. And this is what you would see in a DNS activity log. So these are real queries from this malware family. Basically you have encoded information here, and what you see is different IP addresses here. So this is suspicious because all those IPs, even though they relate to the same domain name, they are completely unrelated, right? And this is first clue that you should be suspicious because it might mean these are not IP addresses but only 4 bytes of information. So it's very useful to check, for example, for a DNS queries to one domain, if the IPs in the replies are from the same autonomous systems, for example. Or, you know, if they are all from different, then it's a reason to be a little bit alarmed. So how do you detect this? How you can detect such communication if you don't know that the domain name is malicious? And usually, you know, we are talking about advanced attacks. In advanced attacks, they will not use a domain which is already known to be bad, right? So you don't know. You cannot work based on the reputation on the IOC level because they will have a special domain, probably even aged, well-behaving in the past, and with good reputation, basically, right? So relying on the reputation here is not good. You can do signature detection if you know the specific malware family. If you know the specific tool, you can build a signature and look in the network traffic for this, right? Like we've seen in the Anchor DNS, there is some template how the queries are built. But before the attacker, with mostly zero cost, he can change this way of building the queries. Let's say he moved hostname from the first place to third. And then the signature will probably not trigger because signature is expecting specific traffic pattern. And here it will be different. So you can do that, but it's also not hard to basically bypass. So this is working on a, if you know pyramid of pain, I would say that's a network artifact level. Then you can check behavior because this traffic we have already seen has some typical behavior, like IP addresses are in the replies are basically not related to each other, right? There is a high entropy in fully qualified domain name. There are some specific things which you typically see in this kind of traffic. So we can do all these 3 things, but the behavior-based analytics is, let's say, most successful. How we do that? So Infoblox is basically delivering a DNS resolver. It could be on-prem, it could be service in the cloud, whatever. You can do it in hybrid way. You can basically choose the best deployment you want. But it is a DNS resolver which for every query which comes will do an analysis of behavior of these queries. We will check all DNS record types. So it doesn't matter if the attacker will use NS records or SOA records or A records, doesn't matter in the query. But we will also check replies if reply is IP address, for example, we will do just what I said. If txt, we will look inside, check, for example, what's the entropy of data in one query, and also it actually can combine multiple replies all together, and then check entropy of all of them for the single domain. Basically, an algorithm will check several attributes of this pattern. For example, n-gram distribution, which is quite a cool feature actually, because it works like this. N-gram is a sequence of n characters. So b-gram, 2 characters, 3-gram, 3 characters. So the query comes, we take first 2 characters and we check, are those two characters together popular in natural language? Like we see letters A and D. You have plenty of words which contains A and D together, right? So it's okay, the score is low. But then you check another two and you see QX. How many words do you know which contains QX next to each other, right? So the score goes high. And we do that for every 2 characters and later again every 3 characters. We will of course check the entropy, we will check number, the ratio of vowels, the ratio of hex letters, so A, B, C, D, E, F, because if you have many of them and not the others, then there is suspicion that maybe it's a hex encoded table, right? We will check how many queries were sent in a specific time, if this frequency was, let's say, regular or maybe irregular. We will check the size and so on. So there is no single attribute actually that we rely on, because if you rely on single attribute, it's very easy to bypass this. I have seen, for example, Invisible, the Russian malware, used recently also in Ukraine. Basically, they were sending queries with high entropy, but they added 16 A letters together. If you add the same letter, like 16 times, for example, the entropy of the string will go down. And if you have detection based on entropy, then sorry, it will be easy to bypass. So that's why it's not good to rely on just one attribute. Okay. Another interesting technique, I said, sometimes domains are generated, C2 domain names, and there are some easy ways to generate domain names, and there are some more fancy ways. This one is more fancy. So basically what attacker is doing, he will generate, thousands maybe of domain names from 2 or 3 lists of words, so dictionaries. He will randomly select one word from one dictionary, one word from the second dictionary, and combine them into domain name, right? So then these domain names, they will look like here for example, where you can notice that some words, such as face, is noted here, it's noted here, it's noted here. That's because it was taken from the dictionary for generating the domain name. So they will be repeating these words. So how we find such domain names? Let's say we found one malicious domain name and we want to find out if there are any more domains like this. So we can proactively block. So what we do when we see either DNS queries or just new domain names popping up on the internet, we split them into words, like here, walk plus road, road plus lift. We check if there is a connecting word, and if it is, we draw basically a graph of words where this connecting word is connecting node here in the graph. And those which are not repeated are leaf nodes in the graph. So then you can see how this graph will look like for a healthy host or for a basically unrelated domain names, and how it will look like if in the DNS queries you will have those DGA generated domain names. You will have those black spots which are basically these connecting nodes. So we can actually extract the dictionary without even accessing the malware. And if the attacker will change the dictionary, we can still find out and proactively find other domain names. What we also do is basically we provide threat intelligence. I call it DNS threat intelligence because you can use this name for many things, right? We are focused on DNS. So basically we provide data about threats related to domain names to IP addresses. So if you need any information about IP or a domain name, you send an API request, or you use our graphical tool for security operations centers, and basically you can get information like, okay, what is this domain name? In what kind of attacks it was used, by what kind of APT group, what kind of multi-attack techniques were used, when we have seen it, and so on. Okay, can I have like 3 minutes more?
Yeah.
Right. So basically, When we find something, we put it into our threat intel database. Out of that, we build threat feeds which will go into our DNS service, but also you can use them on any other security device you have. So basically you can query over API and later put this data we have into your firewall, into your secure web gateway, into your SIEM, whatever. Basically, there are several formats we can deliver this data, like sticks, JSON, CSV, Ceph. It's up to you, what do you need. But it's a nice feature because if you ever done comparison of threat feeds from different vendors and you draw a graph, what is the common between those two vendors or 3 or 4 vendors? You will be surprised that basically there is no much overlap. There is no best vendor in the world. Everybody is basically just seeing a part of threats, threat area. So if you can combine more sources of threat information, it's better for you. So here you can do that over API. It's basically included in the license. Okay, so to summarize, so what we do is basically we do several things. We detect, specifically we detect based on the techniques, not only IOCs, but we do also provide, of course, lethal malicious domains and IP addresses. So yes, you can block also based on the reputation. You can respond because, of course, the DNS resolver can block, can redirect. You can also mitigate via different kind of integrations, like with Cisco ICE, let's say. You can mitigate via firewalls by sending some requests to them as well. So you can do more than only on DNS. We also provide threat intelligence, so you can actually analyze the threat so you know is it dangerous to you or not, right? Because maybe it's, well, lower priority and you should take something first. And then we also provide, let's say, identify section because we have IP address database to use by network teams, for example. So then you can get information who was involved in this incident, right? Actually, identify usually is put first because first you should know what you have and then protect. But I think it's also very important in the response phase. So if you really want to know how threat actors are using DNS, this is the way to do it. We provide free of charge. Right now it's about 6 hours DNS security training, where basically me or my colleague Jan, we are sharing our experience from last couple of years, how attackers are using DNS in a very advanced way. So what kind of offensive techniques they are doing. Command and control, how you detect tunnels, DGA, different ways how you do DGA, how you can use the resolvers, topics like how fresh domains are used in the attacks, because it is changing over time, to be honest. Also about pyramid of pain mentioned earlier, about MITRE attack, how DNS is mapped to different techniques. Very common question will be replied on this training as well. What is the impact of DNS over HTTPS on cybersecurity? And also for those which are interested, how attacks on DNS servers, targeted to DNS servers, are done. So if you want such training for you and your team, just approach me or approach Cosmin. Cosmin is here.
Bună dimineața! Dacă vreți să vedeți workshop-ul, am stat în cursul ăsta ca să vă prin surprindere, nu în față. Dacă vreți să vedeți workshop-ul, luați legătura cu mine, luați legătura cu colegii de la Data Core și putem să-l aranjăm. Nu vă spre de cele 6 ore, nu sunt slide-uri de marketing, e vendor agnostic, vorbim de ce se întâmplă în zona de DNS Security, nu despre Infoblox. Și putem să spargem eventual în 2 zile, 3 zile, 3 ore într-o zi și 3 ore în altă zi. Ne vedem aici sau pe afară astăzi.
Thank you.
Thank you.